Today, we're diving into a really fascinating paper. It offers a totally new answer to a puzzle that's been around for a long, long time. Why exactly does Earth's magnetic field seem to go a little bit haywire twice a year?
So here's the mystery, right? Every single year, like clockwork, around March and September, the equinoxes, Earth's geomagnetic activity just spikes. You see more auroras, our magnetic shield gets a real workout. But the big question has always been, why then? What's so special about spring and fall?
And look, this isn't some new discovery. For decades, scientists have seen this pattern, these two predictable peaks in activity. But just because you can see something happening doesn't mean you know why it's happening. And agreeing on the precise physical cause, well, that's been a real challenge.
Okay, so to really get our heads around this new, alternative idea, we first have to understand the mainstream explanations. Right now, there are basically three big theories on the table.
Each of these theories looks at the problem from a slightly different angle. You've got the axial solution, which is all about where Earth is in its orbit. Then there's the equinoctial solution, which focuses on Earth's tilt. And finally, you have the Russell-McLaren model, which points a finger at the Sun's magnetic field itself.
So how do these all fit together? Well, the general consensus is that it's probably a mix of all three. This breakdown from Leaf-Svalgaard over at Stanford gives us a rough idea of the weighting. And you can see the equinoctial theory, the one about Earth's tilt, is seen as the heavy hitter, accounting for maybe 70% of the effect.
But, and this is a huge but, according to the source material we're digging into today, there's a problem. While these theories are great at describing correlations, when this happens, that happens, the author argues they all lack a fundamental physical mechanism. They describe the what beautifully, but they really struggle with the how or the why.
And that is the perfect lead-in to the heart of this explainer, the source's alternative idea, a hypothesis it calls charge recycling. Now, this is where things get really interesting, because this theory takes a fundamental concept and just flips it completely on its head. The standard textbook model says Earth's hot, spinning, molten core acts like a dynamo, and that causes our magnetic field. This new theory argues the exact opposite, that an external charge field from the sun is what causes the core to be hot and spinning in the first place, a total reversal of cause and effect. So what in the world is charge recycling? Well, in this model, Earth isn't just a self-contained generator. Instead, think of it as being part of a huge circuit. It's actively pulling in charged particles from the sun at its poles, circulating that energy through the body of the planet, and then releasing it back out into space.
The source breaks it down into three steps. First, inflow. Now we gotta pause here, because the source uses its own specific terminology. It talks about particles it calls photons entering the South Pole and antiphotons coming in the North. Just note, this is the paper's language, not the standard definition. Step 2, these particles get recycled as they circulate through the planet. And finally, step 3, outflow, where the charge is released back out, mostly around the mid-latitudes.
Okay, so if we run with this charge recycling idea for a minute, how does it change our view of those three standard theories we talked about?
Well, let's start with Russell-McLaren. The author basically says, hey, you guys were on the right track. You correctly saw that the southern field was super important. You just got the math wrong. See, back in the 70s, the RM model gave 100% of the influence to the southern field. It basically ignored the northern field completely. But this new model proposes a totally different split. It claims the sun's charge field isn't actually balanced. It suggests the southern inflow, what it calls photons, is about twice as strong as the northern one. And if that's the case, you end up with a much more natural-looking 2-to-1 split, about 67-33. And here's the kicker. This model provides a physical mechanism for why the equinoctial theory is the dominant one. Earth's tilt isn't just some random correlation anymore. In this view, the tilt directly changes the angle of attack for this charge flowing into the poles, which makes it the most important variable in the whole equation. And it does the same thing for the axial theory. It offers a potential mechanism. It proposes that the sun doesn't emit its heaviest charge from its equator, but from latitudes around 30 degrees north and south. Well, if that's true, then suddenly Earth's position relative to those specific bands becomes critically important. It all starts to make physical sense. But the author doesn't stop there. It's argued that all three of these standard theories, even when reevaluated, are still missing a fourth, absolutely crucial piece of the puzzle. And this fourth factor is a real wild card. It's a charge field that isn't coming from the sun, but is actually returning to the sun from the giant outer planets, Jupiter, Saturn. It's like an interplanetary feedback loop that the author claims has just been completely overlooked.
And this isn't just a vague concept. The source actually puts a number on it. It calculates the charge density of this returning field at about 3.2% of the sun's direct field. So yeah, it's a minor player in the grand scheme of things, but according to this theory, it's a consistent and calculable one.
And here is where it all ties together into a beautiful, crazy bow. The strength of this returning charge isn't constant. It changes based on where the giant planets are in their orbits. The source argues that this variance, this rhythmic change in the planetary feedback loop, is the direct cause of the sun's famous 11-year solar cycle.
When you really boil it all down, the theory we've looked at today is built on a simple but pretty radical idea that our solar system might not be a perfectly balanced, symmetrical system of forces. And it leaves us with a provocative question to chew on. If an assumption as basic as balance can be challenged, what other scientific givens, what other things we take for granted, might be built on a similarly faulty assumption?